Now, we've worked with the parent function of this graph already. I'm going to just quickly go through a table. I'm going to use values of -3, -2, -1, 0, 1, 2, and 3. And I'm going to be a little excessive in this very first one, just to review the parent function of this graph. So I can put in any value that I want for x, because remember, that's your domain. And the domain of these functions are -infinity to +infinity, but I don't want to go too far away from 0, because the further away from 0 I am, I'm going to have a bigger number. And when I take that bigger number and square it, it's unlikely that I'm going to be able to graph that y value on the grid that's provided. When I put a -3 in, -3 squared, so -3 squared is 9. So you put a -3 in and you get a 9 out. When you put a -2 in, -2 squared is 4. You get a 4 out. And -1 squared is 1. So when you put a -1 in, you get a 1 out. 0 squared is 0. So 0, 0 is an ordered pair that is on this graph. And then when you put a 1 in and square it, you get a 1. When you put a 2 in and square it, you get a 4. And when you put a 3 in and square it, you get a 9. And just like connect the dots, we've got enough points on our graph to graph or sketch a nice curve. And that is our parabola. Okay, let's try another. Here we have y equals -x squared. So this time I'm going to, I'm actually going to use the same values, just for consistency. So I've got the opposite of x squared. So the opposite of -3 squared. Now you might want to do the negative times the negative, but remember, we have to do exponents before we can do multiplication. So our exponent makes that a 9, and then the opposite of 9 is -9. So you put a -3 in, and you get a -9 out, which makes sense because this negative on the outside of the function is a reflect over the x-axis. So instead of opening up, we're going to open down for our parabola. -2, that would be the opposite of -2 squared. That would be the opposite of 4. So when you put a -2 in, you get a -4 out. And when you put a -1 in, the opposite of 1 is -1. When you put a 0 in, you get a 0 out. When you put a 1 in, you get -1 out. 2, -4, 3, -9. And you can see the symmetry. So we can see our axis of symmetry here. So there's our axis of symmetry, and our graph has two halves. One to the left, one to the right of the axis of symmetry, and it's completely symmetrical. We should be able to graph those two functions fairly quickly. We talked about how to graph these functions using our second rate of change, or actually our first rate of change. So here we have, if we just look, for instance, right here at half the graph, because we only really need half, and then we can reflect those points over. So here we have 0 to 1 is a change of 1. For our change in x, we have a +1, right? On the x's, going from 1 to 2 is another change of +1. However, for the y's, we now have a change of 3. And then when I go from 2 to 3 on the x-axis, it's a change of 1, but now my y's changed by 5. And we call this the 1-3-5 rule. It's really just a rate of change. So the slope between these 2 points is 1. So we go right 1. Here's your right 1, and then up 1. And that's how we plot that point. So from the vertex, right 1, up 1. From the vertex, 0, 0, right 1, up 1. And then we have right 1, up 3. So right 1, up 3. And that's where our next point goes. And then we have right 1, up 5. So right 1, up 5. And then I take all those green points and I reflect them over the axis of symmetry so that 1, 2, 3 to the right of the axis of symmetry, 1, 2, 3 to the left of the axis of symmetry. And that's how we graph our parabolas when we have y equals 1x squared. Y equals negative 1x squared, same rule applies, but instead of going right 1, up 1, we go right 1, down 1. And instead of right 1, up 3, right 1, down 3. So we're still going to make a change in y of 3, but it's in the negative direction because the parabola is opening down. So we still have our 1, 3, 5. Now our 1, 3, 5 rule changes a bit when we have y equals 1/2 squared. So that's what I'm going to talk about in the next video, is how do we graph these when our a value, y equals ax squared, when that a value is not 1 and when it's not negative 1, because those are the easy parabolas for us to graph. It's when that a value changes that we have a vertical stretch